Hello, I am Ali Bidabadi from the PLM-TME team at Juniper Networks. This video covers a walkthrough of deploying Juniper Transit VPC on AWS. If you do not have basic knowledge of AWS or require more background on AWS VPC, I recommend going to doc.aws.amazon.com or watching online tutorials. Before we jump right in, let's look at a quick slide overview. First, I will explain about VPC connectivity options in AWS. I'll give a brief introduction to Transit VPC and we'll talk about Juniper's differentiators. I will then take a closer look at Transit VPC architecture. Finally, I'll walk you through deploying Juniper Transit VPC on AWS. There are multiple ways to connect VPCs to on-prem user networks. AWS Virtual Private Gateway can be used to extend customers' on-prem network into VPCs, but it cannot be used to interconnect two VPCs directly. One AWS native solution to interconnect VPCs is called VPC peering, which is shown in the figure at the top right corner of this slide. But this cannot solve the problem if VPCs are located in different regions. Also, VPC peering does not undertake any encryption. Now let's talk about Software VPN Option. This option utilizes a software VPN appliance such as Juniper VSRX that runs on a single Amazon EC2 instance. It can be used to interconnect VPCs and connect VPCs back to the user's on-prem networks. This can be achieved with a full mesh design with added routing complexities, or it can be achieved with a simple hub-and-spoke topology called Transit VPC. What is really Transit VPC and how does it work? Transit VPC is a common VPC that serves as a global network transit hub. It can connect multiple spoke VPCs that are located in different regions or even different AWS accounts. Spoke VPCs can then share Transit VPC connection back to the corporate data center. Juniper Transit VPC contains Juniper VSRXs. Two VSRXs are deployed in different AZs to achieve redundancy. This solution is fully automated and uses an AWS CloudFormation template and two Lambda scripts to launch and configure all of the AWS resources. VSRX initiates IPsec VPN connections to the VPN gateways, VGWs, in all the spoke VPCs to establish secure connectivity. Border Gateway Protocol, BGP, is used over the IPsec VPNs to facilitate dynamic routing between the various VPCs. Why should you deploy Juniper VSRX in Transit VPC? First of all, VSRX is the only Transit VPC option with both high-performance routing and advanced security features. It can support at least 128 virtual routing functions. VSRX can deliver next-generation firewall services such as IDS, IPS, App Firewall, and advanced threat prevention to the VPCs. Also, centralized management allows managing all security policies from a single console. Furthermore, it allows applying consistent policies across VPC and on-prem workloads. Another advantage of using VSRX is its high performance. In fact, it is per core the highest performance routing and next-gen firewall virtual appliance available in the market. This can help lowering the cost of AWS resources without compromising throughput. Also, as mentioned previously, Juniper Transit VPC is a fully automated solution. With the support of VSRX Cloud Init feature, as well as AWS Lambda function, no CLI interaction is needed to deploy Juniper Transit VPC. Let's dive in deeper on Transit VPC. The CloudFormation template deploys two VSRX firewalls, each in different availability zones. Each VSRX uses two elastic network interfaces, ENIs, one for its management interface and the other one for its VPN connection interface. Once the Transit VPC and its artifacts are created successfully, the Lambda automation infrastructure is in place to connect the Spoke VPC to the Transit VPC. The first Lambda function, called VGW Poller, polls virtual private gateways looking for a tag specified in the CloudFormation workflow. If the poller finds a VGW with a matching tag, it creates files in the S3 bucket specified during stack creation to trigger the second Lambda function called Juniper Configurator, which will generate and push the appropriate configuration to the VSRXs. The figure in this slide shows the VGW poller and configurated Lambda function interaction to automatically config IPsec and BGP on the VSRX. This diagram shows the topology that we will have created at the end of this demo. The only prerequisite for this demo is to have two Spoke VPCs in AWS West and East regions with one virtual gateway VGW attached to each Spoke VPC. Create at least one Linux workload with two elastic network interfaces in each of the Spoke VPCs. To be consistent with my setup, connect the first ENI to the public subnet for management, and connect the second ENI to the private subnet. Everything else shown in this figure, including the Transit VPC, will be created using the Juniper Transit VPC solution. You will need to download our CloudFormation template from our GitHub link posted at the end of this video. All of our Lambda function scripts are also available at our GitHub repo for your reference. Now let's jump right in. Here is what I have already created. Two Spoke VPCs, each containing a Linux EC2 instance. You can see an instance in Oregon region inside a Spoke VPC. Obviously, the VPC ID in which the instance has been created should match the Spoke VPC ID. I have also created a virtual gateway and then attached that to the Spoke VPC. Then I created the second Linux instance in another Spoke VPC, this time in Virginia region as shown in the demo topology. I have opened SSH sessions to both Linux instances, one to the instance in the Oregon region shown at the left side, and another session to the instance in Virginia region. As explained earlier in this video, each instance has two network interfaces, one for management and a second interface connected to the private subnet. I have added routes to the route table of each Linux instance to make sure each instance has a route to the private subnet of the other instance. There is currently no connection between the spoke VPCs. Let's verify this. And as expected, the host in the Virginia spoke VPC is not reachable from the host in Oregon spoke VPC. Remember to visit the AWS Marketplace and accept the terms and conditions of the VSRX Next-Gen Firewall. If you need more information, check out the link to our implementation guide posted at the end of this video. If you have not downloaded the CloudFormation template yet, navigate to our VSRX on AWS GitHub repo and download transit-vpc-primary-account.template file to a local folder on your computer. We are now ready to deploy Juniper Transit VPC. Navigate to the CloudFormation service from your AWS console. And then click the Create Stack button. Select the CloudFormation template previously downloaded to your local machine. You can see some of the fields have already been populated with default values. However, there are some fields that you must fill in. First, give your stack a name. Next, copy the content of the public key of your key pair here. If you don't have a key pair, create one first. For instance, on a Mac machine, you can use the SSH keygen utility, which is what I'm going to use to create my key. There are two license models that you can choose from, BYOL and license included. I would recommend disabling termination protection. There are many more fields that have been pre-populated, such as S3 prefix, VSRX subnets, and Transit VPC CIDR block. You can change these values based on your preferences or requirements. One important field that you should pay extra attention to is the spoke VPC tag name and value. This tag is later used to identify spoke VPCs to connect to Transit VPC. Based on your corporate policy, allow or disallow sending anonymous data to AWS. The options page is presented next. This step is optional. You can leave the default values unless configuring new tags, permissions, or some other advanced information is needed. Click Next to be taken to the review page for the CloudFormation stack. Review the sections of Template, Details, and Options. Click the box next to the Acknowledge statement and click Create. Next, follow the CloudFormation stack creation progress. This process involves creating all of AWS resources specified in our CloudFormation template. This will take several minutes to complete. The stack creation is now complete. Let's navigate to EC2 dashboard. We need to wait a few more minutes for the VSRX instances to boot up. A good indication to that is when two checks on EC2 dashboard show OK. The output section of the Juniper Transit VPC CloudFormation stack prints some of the important fields for users' convenience. For example, Spoke VPC tag name and Spoke VPC tag value are going to be used to identify Spoke VPCs to connect to the Transit VPC. Let's navigate back to the EC2 dashboard. Well, as you can see, both status checks have now passed. Now let's revisit our demo topology. According to this diagram, in order to interconnect the two Spoke VPCs in West and East regions, each Spoke VPC needs to establish IPsec tunnel to the Transit VPC. Our solution will make this happen automatically once we tag the VGWs attached to these Spoke VPCs. Let's go back to AWS console. First, we apply the tag to the VGW attached to the Spoke VPC in the West region. It will take up to 1 minute before the VPN connections show up, because the VGW polar lambda function polls every 1 minute. You can see the VPN connections are being created. Let's repeat the same steps for the VGW attached to the Spoke VPC in the East region. Again, we need to wait up to 1 minute. The VPN connections are now being created on the VGW attached to the East Spoke VPC. Wait until the state of the VPN connections to both VSRXs changes to available and tunnel status is up and also BGP routes are discovered. We should verify all of these for the VPN connections in our other Spoke VPC. Well, this is great. Looks like all IPsec tunnels are up and BGP routes have been discovered. Maybe we should now verify the end-to-end connectivity from the workload in our West Spoke VPC to the workload in our East Spoke VPC. But wait, let's not forget about one last step. The discovered BGP routes should be propagated to the route tables to which the private subnets of our Linux workloads are associated. There is no propagated route in the route table, so all we need to do here is to enable route propagation. Let's check back the route table. Now it has a new entry in the route table. Obviously, the same steps should happen to the route table associated to the private subnet of the other Spoke VPC. Now we should be able to verify the end-to-end connectivity. And it works. With this simple ping test, we prove the connection between the two Spoke VPCs has been successfully established via the Transit VPC. Let's look at our demo topology one last time. Using Juniper Transit VPC solution, we were able to automatically create the Transit VPC and its artifacts. Also, all IPsec tunnels were successfully created and BGP routes propagated. As you notice, this was a fully automated zero-touch deployment. Throughout this demo, I did not have to interact with the Juniper VSRX CLI even once. Our CloudFormation templates as well as Lambda scripts are located in our GitHub repo posted here. For detailed instructions, I would recommend reading our Transit VPC implementation guide available at the location also posted here. That wraps up this video. Thanks for watching.